In this module, you will learn how to calculate heights and distances using trigonometric ratios. In everyday life, we come across many buildings, monuments, and other structures. The heights of these structures can be found using trigonometric ratios. Let's review some basic terminology associated with finding heights and distances. Suppose an observer is looking at the top of a tower. The line joining that object and the eye of the observer is called the line of sight. The angle between the horizontal line and the line of sight, which is above the observer's eye, is called the angle of elevation. Suppose the observer is standing on the edge of a cliff and observing a boat on the water. The line of sight will be as shown. Here, the angle between the horizontal line and line of sight, which is below the observer's eye, is called the angle of depression. Let's see some examples on how angles of elevation and depression can be used to find the heights of the objects. A pole of height 25 meters stands vertically on the ground. The angle of elevation of the top of the pole from an observation point on the ground is 45 degrees. We have to find the distance of the point from the pole. Let Mn represent the pole and the point from where the top of the pole is observed be P. The angle of elevation from point P to the top of the pole is 45 degrees. We need to find the distance of the point P from the foot of the pole M. Here, triangle NMP is a right-angled triangle. In the triangle, tan 45 degrees is equal to Mn divided by MP. Let's substitute the value of Mn. Mn is equal to 25 meters. The value of tan 45 degrees is equal to 1. Rearranging, we get the value of MP, that is, the distance of the foot of the pole from the point, is equal to 25 meters. Let's look at another example. A boy standing on a tower observes a ball on the ground at an angle of depression of 30 degrees. The ball is located 60 meters from the foot of the tower. Let's find the height of the tower using the angle of depression. Let AB represent the tower. The ball is located 60 meters away from the foot of the tower. The boy observes the ball at an angle of depression of 30 degrees. When this line is joined, a triangle is formed. Here, the side AC makes an angle of 30 degrees with the horizontal AP. Considering the side AC as the transversal of parallel lines AP and BC, angle ACB and angle PAC form a pair of alternate angles. Hence, they are equal. Therefore, angle ACB is equal to 30 degrees. In the triangle ABC, tan 30 degrees is equal to AB divided by BC. Substituting the values, tan 30 is equal to 1 by root 3 and BC equal to 60 meters. We get AB by 60 equal to 1 by square root of 3. Rearranging the expression, we get AB equal to 60 by square root of 3. On simplifying, we get 20 multiplied by square root of 3 meters, which is the height of the tower. The upper part of a tree is broken by the wind and touches the ground, making an inclination of 30 degrees at a distance of 10 meters from the foot of the tree. Find the height of the tree before it was broken. From the figure, let the two broken parts of the tree be AB and AC. Given that the angle of inclination from C is 30 degrees and the distance between the foot of the tree and the broken part touching the ground is 10 meters. In triangle ABC, tan theta is equal to opposite side to theta divided by adjacent side to theta. Tan 30 degrees is equal to AB divided by BC. Substituting the values and simplifying, we get AB is equal to 10 upon root 3 meters. Similarly, in triangle ABC, cos 30 degrees is equal to BC divided by AC. Substituting the values and simplifying, we get AC is equal to 20 upon root 3 meters. Therefore, the height of the tree before it was broken is equal to AB plus AC. Substituting the values of AB and AC, we get the height of the tree as 10 root 3 meters or 17.32 meters. Have a look at this problem. From a point on a bridge across a river, the angles of depression of 2 points on the banks on opposite sides of the river are 30 degrees and 60 degrees respectively. If the bridge is at a height of 10 meters from the banks, find the width of the river. The height of the bridge is 10 meters and the angles of depression of points C and D on the banks are 30 degrees and 60 degrees respectively. In the figure, let us assume AC is equal to X and AD is equal to Y. In triangle BAC, we know that angle ACB is equal to 30 degrees since angle ACB and angle CBP are alternate angles. We know that tan theta is equal to the opposite side to theta divided by the adjacent side to theta, which can be written as tan 30 degrees is equal to AB divided by AC. On substituting the values of tan 30 degrees, AB, AC and simplifying, we get the value of X as 10 root 3. Similarly, in triangle BAD, angle ADB is equal to 60 degrees. Substituting the values of tan 60 degrees as root 3 and AB as 10 and simplifying, we get the value of Y is equal to 10 upon root 3. From the figure, the width of the river is X plus Y. On substituting the values of X and Y and simplifying, we get the width of the river as 23.1 meters. In this module, you learnt that the line joining the observer's eye and the object observed is called line of sight. The angle between the horizontal line and the line of sight, which is above the observer's eye, is called the angle of elevation. The angle between the horizontal line and the line of sight, which is below the observer's eye, is called the angle of depression.